Hey teachers, welcome back to our next lesson in global learning, talking about climate change. And today in particular, we're talking about how greenhouse gases affect the climate and the temperature in which our planet lives. So we're going to talk about greenhouse gases and global warming. And today the students are also going to complete an experiment looking at how greenhouse gas affects the rate at which temperature affects the ice melting at the polar ice caps. Kind of interesting. So starting with our first slide over here. We're looking at the layers of the atmosphere. I just want to talk about real quick with the kids how there are many layers of the Earth's atmosphere. They go up to 100 miles high. It's where you hit outer space pretty much. But pretty much the primary one is the troposphere. Right, this is where we live. This is the oxygen that we breathe. Right, and greenhouse gases all get trapped in this area here, down close to the Earth. Okay. We have a video that talks about what are greenhouses gases and what is their effect, how it works. So it's a little scientific processy about it, and they go into the process of how we even use greenhouse gases to grow vegetables and stuff and plants. And we have two slides back to back, looking at a little diagram of how greenhouse gas works. Okay, how sunlight comes in, all right, and some of it bounces right off the Earth back into outer space. A lot of the light that comes to Earth, though, hits the ground, okay, and that visible light gets turned into heat. All right, the Earth absorbs that energy and turns it into heat. And then some of that heat gets reflected back into the atmosphere, and it gets reflected back in infrared light form. Okay, and this is where the light that is being reflected back out, the heat that's now escaping from the Earth, gets trapped by greenhouse gases. All right, carbon dioxide, methane, water vapor. Okay, nitrogen gets trapped by the gases in the atmosphere, and it retains that energy. It doesn't allow the energy to leave the Earth. And that's a good thing because it keeps our planet warm. But too much of that, we know, makes our planet too warm. Who is the heavy hitter? There are multiple gases that affect greenhouse effect. In this video, we're going to talk about which gases are the worst ones, and some of the ones that you expect to be the worst ones, okay, aren't, and the ones that you don't expect to be the worst ones actually are. So it's pretty interesting. It gets a little sciencey, but it's not too bad. This is a fun segment here. Burger King trying to increase their PR because there's a lot of activists out there saying that cows, in their digestion, release methane, and methane is bad because it's a greenhouse gas, and how cows farting and burping actually create a global warming problem. So we should reduce the amount of beef that we eat because of the amount of methane that cows produce. If we stopped, consuming beef, there'd be less cows, therefore there'd be less methane. So Burger King actually made an initiative to change the diet of their cows such that they produce less methane. All right, Burger King actually feeds their cows lemongrass now, which reduces their uh, emissions, we call farting and burping, by over 1/3. So this is a funny song that they put together to help as a PR stunt. So the kids should get a kick and a laugh out of it. And Bill Nye the Science Guy. What if the Earth warmed up to the point where all the ice on the Earth melted? What would happen? What would our Earth look like? Is what he goes into here. So hypothetically speaking, if all the ice melted, what would it look like? This here is a simulation. If all the ice on the Earth, on the planet melted, what would the surface of the Earth look like? Because obviously, if all the ice melts, the ocean is going to rise. If the ocean rises, some cities like New York, which are on the waterline, all of a sudden they disappear. They go underwater. So this simulation shows how the Earth's surface will change. This one here shows a diagram of the eastern seaboard of the United States. Everything in blue and purple here, right, will be underwater if all the ice in the planet melted. Florida disappears completely. All right. New Orleans, bottom of Mississippi, all right, Houston, Texas, gone. In up north, New York City, Philadelphia, Washington, all gone, all completely submerged in water. Cape Cod, gone, if all the ice melted. So here's a picture. I've pieced together 3 images, okay? What you see in purple is not the ocean, okay? What you see in purple here is land that, if all the ice melts, is now turned to ocean, is now underwater. Like, look at Stratford. It's completely gone. It's underwater altogether. Parts of Bridgeport too. The Thimble Islands around Brantford and the Madison area, all gone. Major parts of East Haven here, all right, where the airport is, all underwater. It's all swamp in that area. So the question is this: kids, can you find yourself on a map? Where do you live, and is your home still existent? So maybe if you live here in West Haven or parts of New Haven, right? Is your home underwater? If all the ice melts, will you be floating away? Now we notice that all of Florida disappears, right? 100% of Florida pretty much disappears if all the ice melts, but only a small fraction of Connecticut, right? The blue here is not water. The blue here is how the altitude, the elevation, right? How close are you to sea level? All right, the dark blue means that that's sea level. All right, the greens and the reds and the oranges means you're like at a mountain, you're higher up. How come Florida goes completely underwater, but Connecticut doesn't, even though we're both on the water line? Well, it's because of our topography, right? Florida is very flat, very little elevation change. The whole panhandle of Florida is all one level, basically from one side to the other side. So the water rises up, it'll basically cover the whole thing. Whereas in Connecticut, as soon as you get away from the shoreline, it gets relatively hilly. I wouldn't say it mountains like Rocky Mountains or anything like that, but we are quite hilly. I live in East Haven, right on the North Haven line, but I'm 200 feet above the sea level. All right, the sea level is not going to rise that much. It's only a few meters that it rises, but that's enough to take out New Haven. A lot of New Haven's gone. All right, Long Wharf, all gone. But the major part of our state will be fine because we have quite elevation change pretty rapidly. Now, on to the experiment. Last week, the students were supposed to gather a bunch of objects to perform an experiment. I made a video of myself doing the experiment. So show the video to the class. It explains what they got to do. We're going to write it into Google Classroom, some explanations again on what to do. But here's a model of what they're to do. They're to take 2 containers, put some dirt in it, then put some ice cubes in it. One they cover completely, and they put a tie around it. Make sure everything's clear so light can get in. The other one there leave open. So this one here models, okay, the global warming effect due to greenhouse gases. The gases are trapped inside the container representing the Earth, its atmosphere. The dirt on the bottom represents the Earth itself, and the ice that I put in represents obviously the ice caps. Put the 2 side by side at the exact same time in the same daylight and put a timer on. Which one melts faster? Does the one with the cover on it melt faster, or the one that's not covered? The one that's not covered represents the Earth with no atmosphere, no greenhouse gases. Okay, which one melts faster? Interesting phenomenon that occurs here. So hopefully the kids will record that time. They'll take a picture of their experiment, their setup. They'll record the times and they'll post those times and observations in the Google Classroom. We should have some discussion then from everybody's results about which one melts faster. That is the whole lesson for this week. All right. If you got any questions, feel free and email me.